Okay. This is some of the topics I want to talk about today. I'm not really going to talk about stats in the sense of modeling and risk adjustment, summarizing, but purely about the communication. So I suppose I'm starting from the point of view that you have the analysis done. You have the adjustments, you have the confidence intervals. Close. Good. Excellent. And you want to turn those numbers into some visual format. So obviously there is, as I say in the handout, there's a lot of options between text and tables and graphics. And the classic decision is try to put it in text as far as possible. Everyone can speak the same language as you, and there comes a point where it becomes very repetitive and no one's going to actually read it. Switch to a table. And there comes a point where the table is quite complicated or long, and it might be easier to convey the message graphically. And that's the kind of classic statistician's viewpoint. So it's skeptical about graphics. It's like the presentation format of last resort. But things seem to be changing quite a lot in the last few years, and I got interested in this. I was first, as Yvonne said, I'd seen Hans Rosling's video, which I think I've got a link to later on, with his dots for each country flying around the room. And if you've seen it, you know immediately what I mean. It's quite memorable, and I thought, wow, I want to do something like that. And that was, I don't know, 3 years ago or something like that. And I spent quite a while playing around with animation and trying to make a video file out of a series of graphs of your choice, which was very successful. I thought, this is great. Actually, it turned out no one was interested, or very few people were interested. Yvonne was interested, which is nice. Very few people were interested because, in the meantime, interactive graphics was the new big thing, and that was the cool thing to be involved in if you're interested in visualization. And you know, the proliferation of new words for graphs and charts is sort of it's a sign that there's something trendy going on. In fact, depending on how good your eyesight is, you'll see that I couldn't resist calling the page that these slides are on, data viz with a Z on the end, you know, which is one of the many terms that's sort of circulating around. So it's very cool and trendy, but this is what I want to cover. Visualization from a kind of stats perspective. In that age where statisticians are starting to talk to the designers again and making use of new tools. Back to basics, what makes a good, and if you hate visualization, then you can just mentally find and replace it with graph or whatever. What makes a good visualization? Also, I alternate deliberately between an S and a Z in the word because nobody seems to know what to write. Some specific options about audit data, and I mean audit data in the broadest sense. I mean, you have a bunch of units, clusters of data, which might be a hospital, it might be a surgeon or whatever, and you want to compare them. And there's uncertainty, you're operating under various sources of uncertainty. What's all the trendy stuff about? What are the new tools that are being used, and specifically, how accessible are they to you? So I don't want to talk about things that are, you know, require you to go off and do a master's degree in computer science or something like that in order to access them. I'm thinking in here of tools that are accessible by sending someone off for a couple of weeks to learn how to use them with a book. You know, I'm not talking about expensive courses, and I'm definitely not thinking about hiring in a web design firm. I'm thinking about stuff that teams can access themselves. So how can mere mortals make these interactive graphics? This isn't just about interactives, but it does play quite a big role. And obviously we'll have lots of nice examples, and we'll have some bad examples, because it's kind of obligatory in a graphics talk, a visualization talk, to laugh at people. The whole idea of statistics meeting design is an important one to bear in mind. So we have this tradition of real caution about style over substance. That's coming from the stats angle. And this is drummed into us. This is how we're trained. You've got to be really cautious about these people who do stupid graphs. And it's meaningless and it's misleading. And no one understands what it means. And, we could be here till Christmas Day looking at just examples of bad graphs. And it would be very entertaining, but we probably wouldn't have learned very much at the end of it. Coming from the design angle, you have all these people who are actually using the tools, who are actually making things like interactive websites where you select what you want to see and filter the data and you get a graphic of your choice. They're typically designers. There's very few of them actually coming from a stats background and doing that at the moment. So they don't get this caution about style over substance drummed into them. They get an enthusiasm for novelty. To be a successful web designer, you need to obviously have a portfolio of really cool stuff, and cool stuff means something that no one else has done before. So that is valued in that industry, and that makes for this disconnect between the two sides. Notably, maybe, I don't know if this is notable, I thought of it yesterday. I thought that's a really clever point, so I wrote it down, so I'll tell you anyway. In this context, people coming from the stats, the data analysis, data collection, data management side, which is probably you and me, are based in the public sector and probably have been for some time. The designers that you might hire in to make the website for you are almost invariably private sector. And maybe there's a sort of another misunderstanding there about what motivates us both. I also have some notes on a napkin. But nothing to mention just yet. Good. Right. Most of these slides, you notice at the bottom it says there's 55 slides, but don't worry, because a lot of them are just little pictures. So these are 6 objectives of why you might want to visualize data or stats. And they come from a paper just from last year. Everything is very recent in this field. Except for the things that aren't, by Gelman and Unwin. I thought I had a link here, actually, to a web page where you can access that. If I haven't... Yes, it's in the handout. So you can follow the link there to someone's blog page where they've got the Gelman and Unwin paper, 4 different responses from graphics people, and then Gelman and Unwin's rejoinder. So it makes quite an interesting debate about what are you trying to achieve and why would you try to visualize information like this. And these guys are statisticians, and they approach it from our direction. There's a much longer history of designers and to some extent psychologists interested in perception approaching it from the other side. And they've been writing the purposes of visualization for much longer. Don't show this alert again. Good. But Gelman and Unwin's paper is perhaps a little more accessible to thee and me because they start from basics, that they have some information, they have a message, and they want to convey it. And their conclusion essentially is that one image is not enough. You've got multiple purposes, and they're all valid. And interestingly, if you look at their 6 objectives, the first 3 are about conveying the data. Just here it is. I'm not making a judgment about what you're going to find interesting. I'm just giving you the data in a format that you can explore. 4 to 6 are about conveying a message. I've got a message, which is care is much better this year, or care is awful in this part of the country, or whatever. And I want to get that across clearly. Now, this is the old tension, style and substance. And we are obliged to, I use the term statisticians, perhaps a bit loosely there, we are obliged to remain objective and cool and disinterested. That's the tradition. But of course, life isn't quite like that. And we do have messages we want to convey. And clinical colleagues will come and say to me, how can I get this message across? And sometimes there's then a sort of a balancing act between making a really forceful point and a really careful, measured point that no one's going to listen to. And finding the middle ground is that tension. But I think it's quite interesting to think in this day and age that you could try to cover all the bases and have multiple images. In terms of graphics, why not have more than one picture? Now, the problem is, of course, if you're writing stuff for peer-reviewed journals, you know, you've got to have maximum two figures or something like that. They're going to be black and white. So there are some restraints on what we can actually publish. But as you move towards online publication, there isn't that limit. That's been lifted. So the characteristics, I like this idea. It comes from a guy called William Cleveland, who's a sort of information visualization designer. So he's coming from the other side. He says you've got numbers, you translate it into a picture, and that maybe helps people to see the whole scene that's going on, but it only really works if they can, in their head, translate the picture back into numbers. If you can't do that, it's questionable whether that graphic has served its purpose. And then I've just tagged on the end there, and do so easily, because if you have to spend all day working out what's going on, then it's not a great visualization. My own point as well, introduction and or example, and the reason I say that is because I've been interested in this field only for just a couple of years, but a lot has happened in a couple of years, and I see a lot of really clever work that sits online or in a report with no introduction, no explanation, or such minimal explanation that you can't work out what the hell's going on, which makes it completely useless. And I think we don't really concentrate enough on the introduction and the explanation. And it's like guiding people into understanding what's going on. They're going to explore the graph, even if it's just a histogram in black and white, even if it's very basic. They're going to explore it with their eyes and their brain, and you need to guide them into doing it. So you need an accessible introduction. I kind of like to call it a prolegomena because it's the best word for it, and it's also funny because you shouldn't use words like prolegomena in it. This is my all-time favorite. So New York Times have been ahead of the curve for quite a while. The Guardian also do a lot of online graphics, Washington Post. And you can probably think of some outlets that you shouldn't look at for good graphics, like Fox News. I really like this. For several reasons. So I'm going to spend a couple of minutes looking at it. And it's about budget forecasts in the USA. And this came out in 2010. So it's not, strictly speaking, the latest technology in the way that they've made the graph, which I'll go into later. But the way that it's laid out, and the way that it looks, I think is great. It's a masterclass in how to set these things out. So they have up on the top left there, these 6 steps that they want to guide you through, and then you can start exploring the data for yourself. A very short little piece here telling you what's going on, and you step through the 6 steps, and at each step you get a little bit more information. If you put it all down there as a big couple of paragraphs, chances are people aren't going to read it. This just steps you through one step at a time. If you were doing this on paper, you could have the 6 graphs. Step, 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 step. Here's how to read our graphs as an appendix. And once people have worked their way through that, then they can start really exploring. So this is talking about it, at each year you have these budget forecasts of whether the American economy is going to boom or bust. And what they've done is this really quite nice layout with the single dark line, which is reality. And then they've got these pale lines going off it, which are the forecasts, and they depart at the point where the forecast is made, and they go up or down, depending on how optimistic or pessimistic the forecasters were. You have a little bit of animation. It's not that hard to do once you look into it. And I don't know how clear it is to see the lines, but you start to see these forecast lines moving up. They stop at this point, and it gives you an example. So this is what I meant at the beginning by an example, that you might say, this is how to read this graph. Look at the point in red. That is James Paget. In 2012, they had this result. In 2013, they have this result, as you can see from the graph. And once you've talked people through an example, then they can go off and look at the others. So that's basically what they do here. 1995 forecast for 1999 does not predict a surplus, kind of flatlining. Reality was a bit more positive. 2008 forecast for 2012 does predict a surplus. As we now know, that didn't actually turn out to be true. Whoops, a daisy. And we're getting towards the end of the introduction now, and what you start to see is these little streamers, sort of as if they're blowing in the wind, going up off the dark line of reality. So the message that at each point, at almost each point, the forecasters have been over-optimistic is made really clear. But if you just jumped straight to this, first of all, people wouldn't really get it. And that explanation, that introduction step by step is critical. This is a really valuable graph, and it gives you more information than you could get from a newspaper article. It gives you more information than you can get from a press release or executive summary in an audit report. And crucially, of course, it's also kind of interactive because you can hover your mouse. And the point where you're hovering will then get highlighted, and a little bubble will pop up and tell you what the actual numbers are. That's fairly minimal interactivity. All that happens is that when the mouse moves over the point, it shows you something, some further information, the actual numbers behind the scene. So technically this is made in Flash, and that means that it's a series of videos, and there's a degree of interactivity you can have with it, but you can't actually get at the nuts and bolts behind it. You can't get at the whole data, which might be what you want to aim for, because you might not want to put all the data out there. The more recent alternative, I mean, this is only 4 years old. The more recent approach would be to make the visualization in the browser itself. So in the language of your internet browser, so JavaScript basically, and that entails putting all the data out there, the instructions to make this picture, and then your computer makes the picture from the bits. That means you put the data out there, but or a selection thereof, or some summary statistics that you want to draw, but it also has the advantage that it's on the reader's computer that any filtering and selection is done. So they do all that computation at their end. You just give all the instructions and they filter it. That gets you away from a position where you have to have some sort of fancy analytical program on your server that people can access around the clock. And of course, people get annoyed when it doesn't work in the middle of the night. So JavaScript is the alternative. I'll talk a bit more about that shortly. But I really like this example, not only for the design, but especially for that introduction. It's very measured, and it just gives enough to take you into it without overburdening you with information. So it's just the right balance, I think. If you just wanted to have the top line message, you might just flick through the 6 points, read the text, look at the picture, off you go. If you were particularly interested in a particular year, then you could go and you could hover and you could get the actual numbers and start doing something else. Right, familiar formats. So this is important. You know, there's all this fancy stuff out there, and the reason why a lot of it falls flat is because people don't know what it is. They don't know what to make of some sort of weird graph that you've never seen before. But people know about line charts and bar charts, and they know about histograms, and they know about box plots. Wow, I like to think they know about box plots. And they know about scatter plots and things like this. So if it fits into a familiar format, use it. The designer, of course, will want to do something a bit innovative, but your goal is to be understood. So the familiar format gets you past a whole bunch of introductory blurb that you can just skip and show people the stats. Familiar formats don't work if you mess them up. So I saw this in the foyer of St. George's Hospital. And it's audit data, of course, tut, tut, tut. Apparently it's a box plot. Anyway, you can look at these slides at the end. I'll show you the link to them if you have got laptops and stuff up. You can go and look and you can see the pictures in a bit more close up. But down at the bottom here, sponsored by GE, imagination at work, it says at the bottom of the poster, and you'd have to have a lot of imagination at work to understand what that graph is about. It's not as though they didn't have a statistician in the building. They couldn't ask. But I don't know how you could make that, short of opening up Paintbrush or something and starting to daub some lines on the screen. I don't know how you could make that graph. Anyway, so the one issue about defining quality in visualization is that we don't generally know what works. There's some old psychological studies about perception. You show people different images of information, and then you go back a couple of weeks later and you ask them, you test their recall or their comprehension at the time. People don't really do that anymore. People have never really done that with tables or text. That's all about graphics. You can do fancier things now. You can have eye tracking, so the webcam is following your eye and you actually work out what part of the image people look at. That's very trendy, but it kind of doesn't really tell you about the comprehension. What's really easy to collect is, whether people click and go through to further layers of detail, but that doesn't actually mean they've understood it or that they like it. So it is quite tricky. We've got lots of expert opinion. Brilliant. Lots of expert opinion. It's not worthless. We mustn't throw it out, but obviously it is. There's a lot of different opinions out there. There are lots of conferences. There's a huge amount of work goes on in this, but it doesn't intersect with statisticians. It certainly didn't intersect with me until I actually started Googling data, graphics, conference, and then I found there's all these ones that have just happened or are happening in the next year all around the world. And these they've got more of a web angle or a computing angle or a kind of accessibility angle. They don't really intersect with what we do, but there is a huge amount of work going on. Empirical work into what is an effective visualization and what isn't. One thing I picked up from a book which I think I recommend in the handout, Design for Information, is that your brain processes the location of stuff through a completely different set of connections than it processes the shape and color of the object. So you've got this sort of position of things, and I guess that's how you spot the tiger that's creeping up on you in the jungle, or not. And the message from that for me is that you've got multivariate stars where you're defining the shape of something based on a whole bunch of different values. They're not terribly well understood, because the location of it is perhaps variables x and y, and then the length of these little petals coming out is another 10 dimensions, another 10 variables. So that, this is from OECD. You can follow the link from here, and it's a kind of quality of life web page. Some people love it, but I don't think they've thought about it very much. Just cramming everything into one picture is not necessarily a great idea. I think that's pretty awful, but it was Significance Magazine's graph of the month. Some people do like it, but it was interesting for me to think I don't like that, and I'm not sure why I don't like it, and then to find out that there is a kind of perceptual reason why it doesn't really work for me. X and Y, we have this great temptation. I've got two things I've measured, the length of stay and the standardized mortality ratio or something. I'm going to put them on a scatter plot, X and Y. I know how to deal with that. But actually, it takes a bit of thinking to grind your way through, right, that's up there, therefore this hospital's got long length of stay and high mortality. Right, okay, I've got my head around that. And then you have to think your way through it. So it's not immediately natural to sort of force yourself into thinking along those lines. And one thing that does work quite well in terms of X and Y is if you have time going left to right along the horizontal, because that's so drummed into us. It's how we read, If you think sheet music is a graph where you've got time and pitch, and there's loads of other symbols, and sheet music actually is a terrible example of visualization. You can learn a lot from road signs, because we used to have all of these hundreds and hundreds of different symbols, loads of text, and it was different in every county. And you had to slow down at the crossroads to try and work out what that is. It's not terribly obvious to me that a flaming torch means a school. But, you know, at some point in the 50s, 60s, 70s, I forget, this was all standardized. And it was standardized on the basis of studies of perception, what people could absorb really quickly, because it's life or death, you know, that you need to understand what's around the bend. So there's some lessons there about really limiting the range of symbols, colors, shapes, and really limiting the text that's on the page, because text is going to really slow you down. If you do have text, then for goodness sake, don't have some fancy font, because it just takes extra time to be absorbed. And the more time you ask of the reader, the more likely they are just to give up. But yeah, you can have some familiar symbols. You know, we've got flags here. So this is the amount of chocolate consumed in different countries, and then the number of Nobel Prizes they've won. It's a powerful correlation. That's why you're all here just after Easter. So that helps. That's fine. I mean, maybe because it's not too busy, they don't obscure one another. But that's quite nice, because I can find the UK really quickly. I don't have to read all the text and look at them one at a time. So sometimes symbols can help with that sort of thing. Now we have this term chart junk, which comes from Edward Tufte, who is opinion leader from the design side, and his message, and this is going back 20 years or so. His message is, you've got to limit the amount of ink on the page, and if you think about the ink to data ratio, you want to keep that low. You want to have as much data as possible with as little ink as possible. And obviously that's just that kind of a rough guide to help you remember things. But Bateman and colleagues, they did a little kind of recall and comprehension experiment where they showed people what is essentially chart junk, you know, because this is the sort of thing, you do see this sort of thing in the newspaper. And they constructed a boring version of the same data, and lo and behold, people remembered a couple of weeks later, they remembered the woman with the graph paper tights, and they didn't remember the boring line. So it might be the case that a bit of elaboration and junk could help recall, but I guess it depends on the quality of the junk. So as you perceive distances really clearly with things like lines, it's very tempting to deal with areas. And I don't suppose any of you are probably doing this sort of thing at the moment, but I'm sure the temptation is never far away. So this dropped through my letterbox about a month ago. Areas we know are not perceived terribly well. I got the ruler out as soon as this arrived. I thought, I'm going to catch them out. But they had actually scaled it appropriately. The icons are not the best idea, because some parts of it are very faint, or indeed non-existent. There's a little shadow underneath the flames. And it's not a great idea, but they did scale it appropriately so that, you know, the area is going up, not the radius, in proportion to the data. Unfortunately, that's not how our brains perceive it. Apparently, if the radius is doubled, we don't perceive that as a quadrupling of the area. We perceive it as something in between linear and squared. So it's imperfect. And obviously people make all sorts of horrific mistakes with this. So this is an example where you've got scaled by the radius. You know, the height of the light bulb is indeed double. Japan's light bulb is double the height of China's, but that means it's 4 times the area. So, and yet your brain is perceiving it as around about 3 times the size. So very difficult, very difficult. And that's the reason why pie charts are frowned upon by all and sundry, because it's all about area. This is another one that's like the next day the water bill arrived, and this had a horror in it as well. That's brilliant. I was in my element. I mean, not only is it a pie chart, but they've actually kind of extended the top to make it look like a drop. So here you have the designer's gone mad. And nobody put the brakes on. Yeah, that's a pretty bad idea. If you want to get really geeky, you can look at my blog where I actually kind of get the computer to count the pixels and tell me how far out it is. But anyway, this is not unusual. I could show you dozens of examples like this, like a pie chart or donut or whatever. That does not add to 100, and there's no explanation of what's going on. Not to mention the color scheme, because two of the colors are the same. So what are we supposed to, is that significant or what? Now, what if you have got a load of different volume, different quantities that you'd like to depict in that kind of way? And this is an alternative. I have nothing against this. This is the waffle plot or the square pie plot, but that doesn't really make much sense to me. But there are some good examples out there, and it is quite an intuitive way. It does feel quite intuitive that you're looking at quantities now. Of course, it's a little bit approximate. You're rounding things off to blocks, but it gets the message across. The classic response to that is no, mustn't do that. Just have lines. And this is the classic statistician's response to the same data that's in the waffle. And you can see here that, that's a bit bigger than the one above it, which is a bit bigger than the one above that, which maybe is hard to appreciate here, but it comes at the cost of being really boring. In this one, I think it's very hard to tell which of the slices is biggest. It's easy to tell which one is biggest. It's the next three that are tricky. So the pie chart is not much use for comparison. And obviously, you should only use it where you're talking about parts of a whole. You're not going to have standardized mortality ratios from different hospitals, 200 hospitals in a pie chart. Because you could do that, your computer will draw it if you ask for it. It's up to you not to draw it. Audit classics. So when you're comparing, there's a few things that keep coming up. And the caterpillar looks like a millipede, I suppose, millipede plot. David Spiegelhalter's papers are really the one to look at in terms of explaining the funnel plots. So I'm not going to go into the stats of how it's constructed other than just simply how to read it. There's a dot for each hospital. Yeah, there's a dot for each NHS acute trust. And in the plot on the left, the caterpillar, you've got a horizontal line around each dot that tells you basically the degree of uncertainty. It's the confidence interval, so the degree of uncertainty in that estimate. Because perhaps they have a sample of data. And that sort of S shape is typical of a normal distribution. So you've got some outliers at the bottom and some at the top, and most people are in the middle. As you move out to the outliers, sometimes the confidence intervals get quite wide because they don't actually have that much data, and that's why they're an outlier. So drawing the line on there helps you to see that maybe we don't phone the GMC just yet. The funnel plot is a little bit more subtle because it's taking into account the size of the sample explicitly. And so the number of discharges from hospital is along the horizontal, and the percentage readmitted is on the vertical. Now, as you get more discharges in the data, you'd expect to have a really more precise estimate of what's going on. And so you have this funnel. At the beginning, if you don't have a lot of data, you're allowed to be quite a long way away from the national average or the target or whatever, because it could just be chance. But the funnel suggests that as you go up in terms of the sample size, you better be on the money, otherwise we're going to know you really are a bit dodgy. So you can draw funnels of different degrees of certainty, analogous to 95% confidence interval, 98%, 99%, 99.8% in here, and then see how likely or unlikely it is that a hospital could be outside that funnel just purely by bad luck, just happen to be a bad batch of patients, or whether they're really is something worth investigating a bit further. Cumulative funnel plots, I think, quite interesting. I really like this. Yeah, I like it so. I like it so much that I put the citation in twice there. You see, really love it. And this hasn't really been taken up very much. I think it's quite a nice way of explicitly saying, look, as we accumulate data, especially if you've got real-time data feeding in for every patient, we're very uncertain at the beginning, and then as it accumulates, it sort of settles down, and we start to get an idea of whether this cluster of data, surgeon, hospital, whatever, is in the normal range that we've set, near the target, near the average, or whether it's outside. And you do get false alarms, because as you go along, it might flick over the boundary a couple of times, and then it settles down. But I find that quite helpful. I mean, that was, so I suggested that to the Spiegelhalter. So why don't you use more cumulative funnel plots? And he said, because you get false alarms, and we don't really know how to deal with that. And that's true, but I think it helps people to face up to the fact that there are false alarms with dichotomizing and saying this is outside the boundary and this is in. And actually, you've got to be a little bit skeptical about this, and it forces you to think about it rather than just follow a kind of flowchart approach to classifying. Animations, if you've got any video and you've mapped some other variable into time, so the time as the video plays, what's happening, what's changing over time is not time. It's actually, you know, the popularity of the Boris bike station, and this is what this guy's done. And he, you know, to his credit, he says on the page, he says this is an experiment, and it is an experiment. It's quite interesting and informative because it doesn't work, so we know not to try that again. When I looked at it at first, I was really confused for ages. I thought, okay, it's early in the morning, and everyone's waking up, and they're borrowing their bikes, and they're cycling around London. But actually, that's not what's happening at all. It's nothing to do with time. So beware of the powerful draw of time on people's perception. You know, this is kind of stats 101, really. Print it in black and white, because have a look at it, because you know, you're releasing your information into a resource-poor environment, and people are going to print it in black and white. I include this one. Obviously, there are thousands of examples like this, but I include this one because it's the same Gelman who told you how to do good visualizations, and then you can see him making a little slip there. But, you know, we all make slips. This is agonizing because someone spent a long time making that map, and then it just got printed in black and white anyway. Oops. Right, these are my sort of personal take on what makes a good visualization. You need to have that introduction, but it's got to be lightweight. I don't want to see a page of text before you get to the graph, because that kind of defeats the point of having the graph in the first place. Where you've got masses and masses of data, as some of you are moving towards, everyone's excited about big data. Big data's really in. Big data's even cooler than data viz. Are you going to big data viz? Brilliant. And you guaranteed a job with Google if you can do big data viz. So what do? You know, if you've got hundreds of thousands of patients and you actually want to draw a graph, you're just going to get ink all over the page. You can't see anything. You could work on a random sample out of that. I think that's going to be fine as long as the sample's not too small. We know that's going to behave itself well as long as it's properly random sample, but people will be uneasy about it. They're not going to like the fact that you're not showing me all the data. Hadley Wickham, if you follow that link, has this recently proposed strategy of those 3 steps. Group it together like you would for a histogram into bins, count them, or summarize within each of the bins, and then you have sort of the equivalent of loads of box plots, for example, and then you smooth the line through the medians or the quartiles or whatever. So however you want to bin it, however you want to summarize it, however you want to smooth it, that's quite a nice strategy. And it leads you into some pretty neat graphics like, what if you've got something that's naturally like a map. But how do I do a histogram for a map? Well, you could have hexagons, and you color in the hexagons depending on how many. So this is how many Walmart stores there are in different parts of the USA, which is a favorite data set for visualizers, and it just colors in the hexagons depending on the concentrations. This is a two-dimensional histogram. It's not showing you all the data, it's giving you a summary. You can have contour plots. This is really easy to do. It's quite easy to do. So, yeah, homicides in Monterey. It's pretty cheerful. And I'm pretty confident in terms of data analysis software, you could get this out of Stata in recent versions, I think. You can certainly get it out of R. It's interactive only in the sense that it kind of has this little, it highlights one of the contours as you move over it. I'm not sure exactly how interactive that is, but it's, it's zoomable because it's built on an online map. So you zoom, and as you zoom, you get more detail about the streets. And it's actually quite easy to do this sort of thing through Google, but you might prefer to have more control because Google, they own some of the options, really. So rather than masses of observations, what if you've got masses of variables? And this is a problem where you've got lots of performance indicators. Okay, stars, radar, spider plot, you see this stuff around. It is quite popular, maybe not so much in clinical audit. I do see it around in performance indicators, local councils, police. I've already trashed that, so we're just going to move on. Bubble plots, that link takes you to Yvonne's favorite video. Plots. So you can look at that because it's really quite inspiring. But there are some people out there who say this is no good. People don't area of the bubble. People don't like that. It's all moving around, and it's basically a souped-up scatter plot. And one of the bubbles moves in front of the other one and obscures it. This is all a bad idea. But I don't really know what the alternative is. There's some classic multivariate options from the 70s. You can look these up if you like. Andrew's harmonics, well, it's not much cop once you've got more than about 8 variables to deal with. Chernoff's faces, they're quite, they're evergreen. People like Chernoff's faces. You draw a face, and the size of the eyes is determined by the mortality ratio, and the size of the mouth is determined by and so on. And I can't think of a good reason not to like that, but people are obviously very uneasy. It doesn't look professional. It looks a bit silly. Oh yeah, the other thing that I didn't put on the slide there is obviously you've got masses of performance indicators, and you might crunch them down into a couple of dimensions by something like factor analysis, principal components analysis, correspondence analysis, and then if you can get it down to 2 dimensions, then you can draw it. And you could even try to retain as much of the information about the individual performance indicators that went into these 2 summary dimensions as possible. It's like 2 summary scores side by side by drawing something called a biplot, which I'll let you look at for yourself. The problem is if you're not confident about crunching it down into 2 summary scores or 1 summary score, then there's no point in doing it just for graphical expediency. It has to have some kind of clinical validity. Uncertainty has been notably absent apart from the caterpillar plot and the funnel plot. And it's tricky because you're going to add more stuff, more ink onto the page, and it's going to get so busy you can't see the pattern anymore. So error bars are the classic option. You've got a line extending above and below a point, and it says it's somewhere in here, or an area following a curve. And says, well, we don't really know where the curve is, but it's somewhere in this area. There's this idea of overlap intervals that's worth looking up. And that's another thing that hasn't been used because people misunderstand. They think when it overlaps, then they're the same. And when they don't overlap, then they're significantly different. And that's not quite right. But the big problem for me is that people see the boundary as a sharp division. If you're inside the funnel, there can't possibly be anything going on. If you're outside the funnel, you are definitely dodgy. And that is really not true. The terrible results here, you can click through to 3 meta-analyses where they basically get, very, very slightly into a significant result. And they go to town saying this drug is amazing and should be in the water supply, and then another one Well, you can guess. So you've got to be really careful about that sharp division. It's just an arbitrary point along a gradual curve. So an interesting thing is, okay, I've got this really complicated thing, risk adjustment. I've got sampling error because I've only got a sample of the patients. I've reduced the performance indicators into one summary score, but I'm not quite sure the best way to do that. Lots of sources of uncertainty. The alternative to just drawing these error bars is to actually draw your data under many different possible scenarios. And then draw them all, put them all on the page. So I'll show you what I mean by this. Hurricane Sandy is like a kind of the silver lining of Hurricane Sandy is for data visualization. So this is the sort of thing I mean. It's a bit fuzzy, but you have a lot of different weather models predicting which way it's going to go. The way to draw this uncertainty on the page is certainly not to just put the most likely one down. And yet that's what we do most of the time with graphics. We just put the most likely dot down, our central estimate. This is quite a neat way of showing it because it really emphasizes the fact that it could go in one of these routes, but we don't know which one. Maybe it's going to hit your house, maybe it's not. In this one, they don't have a central line because when you have a central line, a lot of people are going to say, okay, well, that's it. And that's the fact. That's the truth. And then they're disappointed when it's not true. So when they say it's going to be 14 degrees, sunny intervals in London tomorrow, you're disappointed because it was actually 16 and it was quite sunny. But it's just the central point. Of course, there's this fuzziness around it. So in this case, maybe the graph is too busy. Loads of points all clustered up on top of one another. But at least it shows all the points. This is like the error bars. There's an area, it's somewhere in here. Now, you know, because you saw it earlier, it could have gone off across the Atlantic, but that fell outside the 95% or whatever it was. This is like confidence interval, but basically they're just crunching down, discarding the outside until they get to 95% of the predictions, which is a general concept called convex hulls. So if you want to show 95% area of anything, any kind of graph, you can just plot loads of them and discard the outer 5%. He says glibly, so there's a little bit more to it than that. And this is kind of the worst of both worlds. So they've got this clear division that would suggest, I live in Maine, there's no way it's ever going to come to get me because I'm just outside the boundary. Phew. And we know that's not true. It's just gradually becoming less likely as you move away. And there's a central point there that most people are just going to look at that central line and say, it's going to hit New York, and not be interested in anything else. And I know, as it happened, it did hit New York, but that's beside the point. So how do we do this trendy stuff? If you want to look trendy, it's kind of half the battle, I think. Which sounds frivolous, but I think there's some truth in it, because you're releasing this stuff to consumers. Clinicians and the public are consumers of your data, and they want it to be professional, and they want it to be reliable, and they want it to be in a format that they can dig their way through. Or in a series of different levels of detail that they can choose how far they want to go into it. Only slightly frivolously, I say, if you don't have time for anything, just use a black background and white text, and everyone will think you're pretty cool. Transparency and overlap, I'll show you in a moment. This is in because you couldn't really do it until recently. You couldn't draw graphs where you had dots or lines overlapping, and you can kind of see the one underneath showing through. And that helps when you've got lots of information there, lots of dots for hospitals, lots of lines, trends over time. When it gets too busy, you might get away with it just by turning on transparency. Color design is important. I mean, you shouldn't do, this is okay, that's really not okay. What are the colors? I've got no idea. Yeah, there's some stuff at the top. I'm never going to look at that. I don't care. That's good. That's really good. You've got a load of faint points, and you've got one that you've picked out with a quite relatively subtle highlight to say, this is the one I want to draw your attention to. For goodness sake, yeah, I said clear font and minimal instructions. Don't overburden people with text. You can look at some of the trendy stuff, but lots of people are doing these stream graphs. awful, pointless. But, you know, it's Gelman and Unwin, objective 6 is just to get people interested and draw them in. So maybe, why not? This is how often people tweet about different countries during Euro 2012. So the naturally periodic nature of the football fixtures means it kind of makes sense. But in real life, this sort of thing is just a mess. Okay. Margins plots are in because you have this really complicated way of working out the confidence interval about the point, even under a really complicated model where you've got lots of different predictors feeding into it, like a risk adjustment. So you can do this now as of a couple of years ago in Stata. You can do a kind of rough version of it using R. I don't think it's not there in SPSS if you're using that, and goodness knows about SAS. But I'm really keen on margins plots because you can show something like, this is a risk difference. This is just from Stata's website, but it's basically a risk difference between men and women for the risk of acquiring a new diagnosis, high blood pressure, when you've got this uncertainty. As body mass index goes up, a whole load of other things change too, and they all interact in a complicated way. Working this out is not trivial, so having the right software to be able to do this, I think, really helps you communicate the point. That's certainly a lot better than a whole page table of odds ratios and confidence intervals coming out of some logistic regression, which is what this essentially is. People love drawing networks, rubbish. People, this is, you know, obesity is contagious, is that one. If you haven't read that paper, then don't bother. Networks, then you could have it around the outside. So this kind of come from genetics. People did this first, and it's kind of useful. Now, now people are doing it for anything. So here you've got a website where you can say what beer you like, if you like American beer, that is, and then it'll show you other beers that you might like too. Great. Tree is kind of hierarchical structures. So I think we are rarely in a position to draw this kind of data where it's really clusters within clusters within clusters, but you know, there is software out there that will arrange those blobs for you in the optimal way for clarity. Word clouds. So this is the transparency. You could have a whole bunch of lines and they all sort of show through each other. So when you've got a lot of them overlapping, that area gets darker. And this really works for an intuitive grasp. I kind of don't really care what they're plotting, some sort of political science stuff, but I really like the look of that because it shows the uncertainty very clearly, and it removes this idea that there's a boundary to the confidence interval within which, you know, things are fine and outside which things are not fine. It really emphasizes that fact that there is some fuzziness. How do you get this transparency? You can do it in R. I have reason to believe it's coming in Stata, but it's a hard job for them to do. But you can just save any picture as a PDF. You can download this Inkscape, which is free, or if you happen to have Adobe Illustrator, similar PDF editing software, you open it up, and then you can go in, select the lines, select the dots, and do some edits to the look of it. So even if you've got pretty basic analysis software, you can save it out as PDF and then do some fancy stuff with the look of it. Why not draw every point? Why not? We've got 3.3 million tweets in English in London during summer 2012. Let's draw every single one on an interactive map that people can zoom into. And I think this is an interesting trend because we just would not have thought of drawing every point before now. It would be ridiculous. But that is a direction people are going in. If you can zoom, if you can filter, then why not draw every single point? There might be kind of anonymity issue here, but in the case of Twitter, you know, we gave it away. We signed up to it, so a little bit different for audit data, perhaps. But that idea of drawing lots and lots, you know, 4 million points or something like that is a trend. Or you could just have aggregate dots, a bit like the hexagons, a bit like the hex bin, and make it look like that, because this look is cool. People want to zoom in. So this is, you follow the link, New York Times again, and you can look at the American census results from New York, and you zoom into different neighborhoods, and it shows you dots as if they were people, but they're not. They're just in proportion to different ethnic groups and so on. Attaching stories is, I really urge you to go and have a look at this one. I would, if I had the chance, I'd run the video and I'd let you look at it, but I know it does take a little while. It's a really powerful example of how you could do something a bit interactive. You could attach stories to the data, because these are coroner's reports, so they're in the public domain. And the effect of the animation when you run that is, it has impact. That is a very powerful message. So I'm showing you that at the end of the video, where we've accumulated 500,000 years lost to guns in 2013. And each of those lines is a projected life expectancy. How they've done it is a little bit fiddly, but it's a really interesting design. You've got lots of mobile devices collecting stuff, so it might or might not be relevant to crowdsource things. I'm not sure that rating your hospital on NHS choices exactly counts as the same thing. But I'm talking about automatically generated stuff. If you have a Gmail or a Google account, you can go to this location history. You probably don't even know that they're doing it. And then you can see where you are now. It'll say you're in Euston Street and you've been here for a couple of hours. And you can download that data. Okay, right. Real-time data. The stuff that's being done out there that's kind of trendy is generally pretty boring, because they just suck it out of Twitter or Facebook. But a couple of things about detecting flu outbreaks is quite interesting. The model, the Bristol model here, seems to have broken down in the last 6 months or so. I don't know why, but it seemed to work quite well before then. And that's my learning curve that I've gone through. So I think it is possible to do this. Like Ken Hom, like I was saying here. If I could do it, then so could you. Because I didn't know anything about interactive graphics when I got started. If you're looking at software, you're thinking about what tool you can use. R is free data analysis, data processing software, and because people contribute user-written packages to it, it's got this huge flexibility. But don't go for the presets like this, ggplot rubbish. You can do a lot with Stata too. I'd like to say something nice about SPSS, but I find it difficult. Easy interactivity, this is the interesting thing, because you could take your data, you could type a couple of lines into R, and it will do all the heavy work and make the website with your chart that you can click on and zoom into and so on. This is not hard to do at all. I know Yvonne is going to hate me for clicking on this, but I just want to show you, for instance, on the guy who made R charts with his examples here. This is the sort of thing we're talking about. You're typing one line. Once you've learned how to do that, it goes off and it makes a web page which contains this interactive graphics. So that is really good, because the web page is going to contain 100 or more lines, but you can just get the computer to do all that heavy lifting for you. Google Spreadsheets, Excel Online, let you, with some limitations, put your data in and click a button and it makes an interactive graphic. But again, the data's out there then. The data's out in the wild. Some points on interactivity, I'll let you consume at your heart's content. D3 is where it's at, by the way. D3 is cool. 3 last examples. Low interactivity, you've got this kind of scale. This is the sort of thing you might do, so this is enough you'll trust. And basically it's a Google map, and they've colored in some bits. And when you click on it, it tells you a number. So there's 8 regions here, and there's 8 numbers. And they're colored in, which is pretty but fairly pointless, because you could just have a table of 8 numbers. There's no more added value from the map and from the interactivity. And there's a selection of different maps that you can pull up, but basically they're 10 pictures or something like that. This is really good, cross-filter. So if you're interested in doing something interactive, go and look at this, because this example that they have, I think, is great. You can filter. Here's the time of day that different planes land. You pull in these boundaries to bracket it. You say, I'm only interested in 8 a.m. to 10 a.m., and then it'll show you how many there were over time, and it will show you how much they were delayed, and all of those histograms update as you move your filter around. It updates live. It doesn't update on the server. It updates on your computer, so you've got control over what you want to look at. And that, I think, is a very promising framework to put things like audit data into. Is there an upper limit to interactivity? I don't know, because this guy has done a web page that actually does the analysis. You type in your data, and you press go, and it's doing it. It's this kind of Bayesian model. It's not something trivial, and it's doing it on your computer in your web browser. So you can actually do something like change the risk adjustment. What if I don't believe age affects this outcome? And you take it out. You allow the user to try different risk adjustments. You could do that. I ran this on my mobile phone in bed. and I made a point of getting into bed, so I'd actually done it. But the thing there is it's portable. It moves across platforms because it's just the web browser. Web browsers, people have invested millions and millions and millions into making web browsers fast and efficient and reliable. And what you're doing with the interactive graphs is you're accessing that power and putting it onto someone's computer, so it makes things a little bit easier. Can I just point out the missing point on the end there is at the British Library, which is just around the corner, there's this exhibition until a month from now called Beautiful Science, which has got some classic graphs. What could be better? It's free. There's no excuse. It really is a block away. So go and check it out. You can see Florence Nightingale's rose and stuff like that. Okay.
Brilliant. Thank you very much.
Sorry to overrun a little bit.
Fantastic. Oh gosh, everyone can hear me. Thank you very much, Rob. My God, I feel like I've spun around the world of interactivity. I'm reeling, I'm dizzy, but it's very exciting, very inspiring. Feels like a million light years from where we are at the moment, but some of it feels like we could get there and is accessible. I'm going to run around with the microphone and take questions. Are we ready to go straight into questions? Does anyone have anything they want clarified or a point to make about where they are currently with their project, what this might mean to them, what ideas this has sparked off? I have a couple I wanted to ask, luckily. So my first question, I'll warm them up. My question was, I had lots really. I was really interested in the part about taking people through a complicated diagram. And the first thing that really sprung to my mind was more and more we're using funnel plots when we do our standard. Most people are very comfortable with funnel plots. For the variety of readers that will be looking at either online or hard copy reports, should we be providing some sort of standard walkthrough of funnel plots? Should there be a link that says, if you want your handheld a bit here, do we feel as a community that there's something in that kind of walkthrough that might be useful that we centrally could generate that could be then used by projects in whatever way they want to, or do we feel that our audience are all totally comfortable with funnel plots? So that's my question to the audience, I suppose. Nobody willing to make a comment? Great.
Rodney Franklin for the Congenital Audit at NAGCAE. Yes. I think it would be helpful to have perhaps even an animation to kick off when you go into your website. These are all the plots in this website are based on the funnel plot, and this is what they all mean, and have a sort of animation, a cartoon animation even, which would take you through this as a naive user, if you like. And I think it'd be helpful for our point of view from going through in families. This is the website you find all our results on, and this will help you go through that. So I would be in favour of that sort of interaction.
Any other comments on that point?
I don't know if there's anyone here from the National Vascular Registry, but they've got a video explaining funnel plots, so it might be interesting if people want to see what other people have done to just give that a Google. It's just on YouTube, but it's pretty good.
Okay, great, because if they have that, that's certainly something we can disseminate or make accessible to other projects, all other projects. I guess my other question...
Pick up on one point on that, which is that you all have PPI, and that's your source of testing out the explanations for these graphics and reports generally, text and tables, because it's often been my experience that the patient rep will say, oh, I didn't understand that, but now it's a bit clearer. And then all the clinicians around the table will say, oh, actually, I never understood it either, but I didn't want to say. So I think using patient public reps to your advantage is potentially really valuable for this.
We have some of our Service User Network members here. Does anybody want to comment on whether they would find from that perspective some guidance useful around funnel plots? Is that something that's come up, or maybe Kim, has that come up in discussions in the network?
Definitely. I mean, generally the feeling is the feeling is that funnel plots aren't very user-friendly, but if they were to be used by having a graphic to explain that, I think would be really useful. Yeah, it's not very patient-friendly. Funnel plots, it's not generally liked, is it?
I think it's a degree of familiarity, because if forest plots in meta-analysis is something that most people in medicine are familiar with now and seem quite baffling when you first encounter them, but you've got to get over that initial familiarity. I'm a little more skeptical than most about just what extra information does the funnel plot add. I think it focuses your attention on the size of the sample, but it is predicated on it being a sample, and it's all about inference. It's not that you've got a random sample and we're going to pull a bunch of formulas out from the 1920s and say what we can say about the population. But in an increasing number of these projects, you have the population. And the only potential inference that you're trying to do is to the future, to next year. And if you know that things are changing in the NHS, do we think things are changing in the NHS? Probably. That might be a fair guess for any year. So do you trust the inference? And what is this population that you're extrapolating to? So it's a bit fraught. But funnel plots are where it's at. That's the kind of the only game in town. And I think we've got to be seen to do what is current best practice. There's nothing wrong with them, but I think they do need explanation.
Any other comments? I had one other question, which really is, I think we're all making more and more use of year-on-year comparisons. So national audits, many are getting older. There is much more historical data, and there is much more interest, I think, out there in tracking changes with time. Do you want to just run back through, in summary, some of those methods that you've talked about that are particularly useful to help people when they're producing reports that are looking on year change?
Well, one thing that springs to mind is that I remember this from RCP days, that you've got to think really carefully about changing your the setup of your scoring system, or which indicators you feed into it, or what the definition is, inclusion, exclusion criteria, because that sort of invalidates the comparison with last year's report. Unless you go back and reanalyze last year's data, which is fine, but then you're going to have two versions of last year's data in circulation, and people start to get a bit confused and anxious about it. And I suppose one of the options is that then you could allow the reader, the viewer, to choose what they want to do. Do you want to see last year's data as it was published versus this year's data as it was published with a footnote? Or do you want to say, make it comparable, and the footnote disappears and the lines jiggle around a bit, and now you've got that comparability. So you give them the option of looking at that. And what you can do is you can hide a lot of the detail then. The information about what was changed is maybe there if you click on the point, then the pop-up appears and it tells you more about. So that whole idea of being able to drill down to the level of complexity that you want, I think, is potentially valuable there.
Okay, great, thanks. We are out of time and I don't want to cut into your coffee anymore. Any final questions or comments? Okay, I think I'll release you to coffee. Coffee's at the back of the room. Thank you very much, Rob.